But now we're going to actually talk about why an acid is an acid and it has those acidic properties and why a base is a base. So, it all starts with this guy named Arrhenius. Can you say that? Arrhenius. Okay. So, Svante Arrhenius first proposed the theory on acids and bases. So we call this the Arrhenius definition or the Arrhenius theory. His theory was that some compounds formed electrically charged particles. Electrically charged particles. When in solution. His explanation of properties of acids and bases is called the Arrhenius theory of acids and bases. So, an Arrhenius acid is a substance that ionizes. Very important word there. Acids ionize. Now, we say it has to ionize because originally it's a molecular compound. So for an acid to have an ion, it needs to ionize. Okay? To form hydrogen ions, or our H+, in water. An acid will increase the H+ in an aqueous solution. Now, an Arrhenius base is a substance that dissociates because it is an ionic compound. Okay? It's an ionic compound, so it dissociates to form hydroxide ions and whatever else it has for ions in an aqueous solution or in water. A base will increase the OH in an aqueous solution. So this is what Arrhenius started with. Now this is really great, but it's not the whole picture, and it doesn't explain why, say, NH3 is a base. Okay? So, oops. Okay. So next then we have to do, we call it a modified Arrhenius definition. So we just took Arrhenius's definition, modified it a little bit. So the original definition of acids and bases proposed by Arrhenius is good, but it has limitations. Some substances that might be predicted to be neutral are actually basic. Whoa. Like ammonia or sodium carbonate. Sodium carbonate actually acts as a base. If we do all these tests, it will be basic. But it doesn't have any OH in it, so what's up with that? Okay, so we needed a modified theory to explain what's going on. It has been found that not all bases contain the hydroxide ion as a part of their chemical formula. So there must be something that happens to still make hydroxide ions. So an Arrhenius base that is modified, it's the modified definition, is a substance that reacts with water to produce hydroxide ions. So for example, if we took our ammonia and we actually react it with water, rather than thinking about dissolving it in water, we actually react it, what ends up happening is one of the H's from the H2O kind of attaches onto the ammonium, okay, and it makes an ammonia ion. And what's left over then from that water? An OH. And because we took a hydrogen away, it's like taking away a proton. So now that is negative overall by 1. Okay? Sodium bicarbonate. If we react it with water, after it's balanced, it'll be 2 water. One of those, we have our sodium ion. Now, one of the hydrogens from the water attaches onto the carbonate. And so I have H2CO3. But see, that one is kind of a 2-stepper. But actually, just maybe I'll leave it. It's like 2 lessons away that I do the 2-step. Okay. So that's how we can get a basic property without having OH in the beginning. So this, even though it doesn't have an OH in its formula, it can still produce an OH with a reaction with water. Okay, so here's kind of the rules for how to do your bases, okay? This is really, really, really super important that you follow these rules. So, bases. What you need to think is you need to make a hydroxide ion. That's kind of your goal. If the base has OH present, just dissociate it. If it is an ionic compound without OH, dissociate it first, then react the anion with water to make the hydroxide. So, let's do a couple examples. So here's calcium hydroxide. You see an OH in it, so all we have to do is dissociate it. So, with calcium hydroxide, there is, oopsies, sorry. There is no need, oh, it's not going to work. I'll make a thing. So there's no need to show a reaction since, or show a reaction with water, because the hydroxide ions are present. So now, for number 1, all you gotta do is dissociate it. So now we have Ca2 plus AQ and OH minus AQ, and I need to put a 2 in front of there. Okay, so that's all you gotta do for that one. Now number 2, we have NaCN. Now since this base is an ionic compound with no OH, you need to dissociate first. Then react with water. react the anion with water. So, it's like you think about it as step A, is you dissociate it. So we have Na plus with Cn minus. Then the instructions say take the anion from the dissociation and react that with water. So this is the anion. So you take that, Cn minus AQ plus H2O liquid. You know you want to make OH minus. So the way you think about it is you take a hydrogen away from the water and it attaches on at the end. Okay? So what you end up making is an HCN. Okay, you take a hydrogen from the water and attach it to the other thing. That's AQ. And what is left over after the water has donated a proton, it's how you think of the water almost as a proton, is OH minus AQ. Okay? And then the last one, we already kind of did it, but we'll do it again. So NH3, again, this one is not an ionic compound, so we can't dissociate it. So we're just going to react it with water. See that? You just react it with water. So you can't dissociate because it's not ionic. We end up with an OH minus, and that H goes and attaches to NH3 to make NH4 plus. Okay. Now, if you're kind of thinking ahead, you might see something here. No, I shouldn't even tell you. I'll save it for Chem 30. Should I save it or should I tell you?
I'll say it now.
Okay. When you do this, what does this look like? It looks like an acid, right? This is called its conjugate acid, because when you're making a base, you always make a conjugate acid. Now, whether or not the conjugate acid or base is stronger or weaker will determine if it's going to be more acidic or more basically, if it pushes to the other side. Right, so that's totally a Chem 30 thing, but it's kind of cool. If you can already see that, that's good. Okay, so next thing. I don't think we have time, okay, for the acids. So that's the bases for Arrhenius modified bases. So in your workbooks, I want you to try, so take out your workbook, and I'll tell you what I want you to try first. You can have it? Okay. For this one, what I want you to do is lesson 2, numbers 1 to 7. Just those ones first. And then we'll do the rest together tomorrow. Okay? So you should be done up to, by tomorrow, page 4, question 7 is for homework. Okay, page 4, question 7. And note that you have a small quiz tomorrow on precipitates and quality.